Welcome to 3 Inquisitive Kids. In this video, we'll be solving a problem about exponents and logarithms. We are given the values for a, b, c, d, and e. Our task is to order them from least to greatest. And it will be difficult to find the exact value of them and then order them. So instead, what we can do is find the range of where their values lie and then compare them together. So let's look at a first. A has an exponent that is between 0 and 1. So a itself has a value between 3 to the power of 0 and 3 to the power of 1. So a is between 1 and 3. Now what about b? b is equal to 5 to the negative 1 power to the negative 3 power. This is the same thing as 5 cubed. So b, we actually know the exact value of it. It's just 125. Now what about c? c, if we rewrite it, we get negative 3 to the negative 1/5 power. This is equal to 1 over negative 3 to the 1/5 power. We can go ahead and take this negative sign out and put it in the front. So we're left with 3 to the 1/5 power. This is the same thing as taking the 5th root of 3 as well. So when we only focus on this part, 1/5 is between 0 and 1. So 3 to the 1/5 lies in between 3 to the 0 and 3 to the first powers. This means that 3 to the 1/5 is between 1 and 3. Now we just have to find where this entire value of c lies. So we take the reciprocal of it, we would get 3 to the 1/5 on the bottom is in between 1/3 and 1. And finally, we take the negative of it. So now we see that c has a value between negative 1/3 and negative 1. Now on to d. d is equal to log base 3 of 1/5. This is equal to log base 3 of 5 to the negative 1st power. And using a logarithms formula, we know we can move this exponent of the argument to the front of the entire logarithm. So d is equal to negative log base 3 of 5. Log base 3 of 5 is greater than 1 because 5 is greater than 3. And here, let me write it out so you can better see. In this case, these two values are equal. So knowing this, if we take the negative log base 3 of 5, that would be less than negative 1. We have to flip the inequality sign. So it means that d is less than negative 1. Now what about e? e is equal to log base 1/5 of, now this is all equal to log base 5 to the negative 1st power of 3 to the negative 1st power. And we can move these two exponents to the front of the log. So it would be negative 1 times negative 1, which just leaves us with positive 1. And we're left with log base 5 of 3. We know that 1 is equal to log base 5 of 5. And so log base 5 of 3 must be less than that. This means that e is less than 1. And is e negative or positive? Well, when we look back at our original logarithm, we see that e must be greater than 0. So e is between 0 and 1. Now we can compare a, b, c, d, and e. The letter with the smallest value is d because it has to be less than negative 1. The second smallest would be c, and then it would be e, then a, and finally b. And there we go. We have ordered these 5 numbers from least to greatest. In this problem, we didn't have to find the exact value of each of these letters. All we had to do was zoom into where these numbers approximately lie, and then we can still order them from least to greatest.